Consuelo, everyone. Okay, today we're going to start just introducing, like, what's this chapter about? The exponents that we talked about last time, they're pretty much like an introduction. It's something that you need to understand in order to understand polynomials, okay? And what makes a polynomial a polynomial? A polynomial has a whole number exponent on the variable. Now, obviously, in order to understand that, you have to understand what a whole number is. Okay, well, back at the beginning of the year, I went through this, but I'll tell you again, what's a whole number? Okay, real numbers are everything. Integers are negatives, positives, without fractions or decimals, like -3, -2, -1, 0, 1, 2, 3, et cetera, et cetera. Okay, if you take away the negatives, you've got the whole numbers. So the whole numbers are 0, 1, 2, 3, 4, et cetera, without fractions or decimals. Okay, so there's more than that. It's not just that it's a whole number. It's not even that it's a whole number exponent. It has to be a whole number exponent on the variable. That's what you're looking for. If you want to know whether something's a polynomial or not, that's what you look for. So all I want to do is look at these and say, yes or no, is it a polynomial? And if it's not, why not? And if it is, I guess why it is. Okay, so the first one, exponent 7, that's a whole number. It's on the variable. So yes, that's a polynomial. Okay, the exponent here is not, on the variable, is not a whole number, because whole numbers don't include the negatives. So this is not a polynomial. Okay, number 3, right? Whole number exponent. It doesn't matter that there's a negative out in front, okay? Is the variable exponent a whole number? Okay, number 4, take a look at the variable exponent. What is it? It's understood to be 1, so it is also a polynomial. This one doesn't matter, okay, because it's not on the variable. Okay, number 5 is a little tough, all right, because you could say, well, there's no variable. Well, actually, I can write it as 13x to the 0 power, because remember, x to the 0 power is 1. So because 0 is a whole number exponent on the variable, this is a polynomial. Okay? Number 6. Number 6 is the same as number 5. What's the variable? X, or x, it could be x or y. I mean, it doesn't matter what the variable is, but it's any variable to the 0 power. It doesn't matter that this thing is a fraction, because that's not on the variable. So this is also a polynomial. Okay? Now this, though, is on the variable, so this is not, because whole numbers do not include fractions or decimals. Okay? What's the variable exponent on number 8? It's x to the first power. It's understood, so that is. The 1/2 doesn't matter because it's not on the variable. Okay, on number 9, there can be more than one variable, so yes, this is a polynomial. Okay? And all of them have an exponent of 1. 10 has a variable exponent of 1, so that is. And 11 is a little tricky, but remember, this is the same thing as saying x to the negative first. Okay? So it is not a polynomial. All right? Okay, now, if something's a polynomial, huge if there. If something's a polynomial, we can talk about something called its degree. And like, after I show you what the degree is, I'll kind of try and give you an idea of why you should care, or why someone somewhere cares anyway. So let's take a look. What you do is you add up the variable exponents. So here, what's the degree? The degree of this one is not 18, okay? The degree is 19, because it's 5 plus 1 plus 13. Because remember, the y has an understood exponent of 1. Okay, number 2, doesn't have degree. It's not a polynomial. If it's not a polynomial, it doesn't. Degree only applies to polynomials. Okay, and why isn't it? Because that is not a whole number. Once one thing doesn't have a whole number, the whole thing's not a polynomial. Okay, whole number exponent on the variable. Okay, number 3, the degree is 7, all right? The degree is not 10. Why? Because all you're looking at is the variable exponent. You don't care about the rest of it. Okay, for all other polynomials, I'm going to read this to you, and then you're going to go, what the heck does that mean? And then I'll explain it. Okay, the degree of the entire polynomial is the same as the degree of the monomial that has the highest degree. Okay, so let's take a look. Number 1, there are 2 monomials in this. The degree of this one is 8. The degree of this one is 11. Why? Because I add the 7 and the 4. Well, which one's larger? 11. So the degree is 11. Okay, number 2, it's not a polynomial. This thing has no degree. Okay, number 3, this one's 5, this one's 3, this one's 2, this one's 0, because that's negative 14 next to the 0. So the degree is 5. Okay, what difference does it make? It's this. If we're talking about equations, okay, remember, there are 2 types of equations. There are equations you solve, and there are equations you graph. Well, let's consider the ones you solve first. If you know the degree, that tells you how many solutions there are. Now, I'm going to have to, at some point, clarify that a little bit. But in other words, if I solve number 1a here, which I'm not going to do, we'll do this later. Actually, I've already done it with you, but I know I have to have 3 answers. I have to account for 3 answers. Okay, how do I know? Because the degree of this thing is 3. The degree of b is 5. Therefore, if I solve that for x, I better have 5 answers. I better be able to account for 5 answers. And see, I don't know anything because it's not a polynomial, so I don't know how many answers there are, or even if there are answers or whatever. Okay? So providing it's a polynomial, knowing the degree will tell you the number of solutions for an equation that you solve. Now, what about a polynomial graph? Okay? The degree will tell you the number of sections in the curve. Now, what do I mean by that? This graph is going to look like, so problem A has a degree of 3, so there are going to be 3 sections to the graph. It's going to look something like this. Okay? There's one section here, another section here going a different way, and another section here. Okay? Now, it could also look like this. 1, 2, 3. But they're like 3 distinct parts to the graph. Okay? In problem B, degree is 4, so there are an even number of sections, and there are at most 4 sections. So it's 1, 2, 3, 4. Or, of course, it could be 1, 2, 3, 4. And it's going to be more like the second one, because notice the x to the 4th is positive, so it's pointing up. Or it could look like this. 1, 2, 3, 4. Okay, it could also look like that. Okay? So doesn't really seem to tell you much, but believe me, just knowing that little bit will really help when we solve equations, and also when we end up graphing. Okay? All right, that's it for now. So you should be able to identify if something's a polynomial or not. You should also be able to tell me its degree. And this bit about what difference does it make whether you know the degree or not. In other words, it tells you the number of solutions or number of sections in a graph. That's something we'll worry about as the chapter goes through. But that's the reason why. All right. Talk to you later.